Well, what are we up to today? Well, we're doing a video and it includes a doorbell with a strange pair of wires out of it. Let me explain what this doorbell is doing. Well, it's doing what a normal doorbell would do, and it alerts me to people coming onto my property. It does that by means of an infrared perimeter beam that I have across the front of my property, and that's because I don't have a doorbell. I don't have a front fence. I've attached the doorbell side, or the push button side of this, to a little mini DigiSpark, which is basically a baby Arduino, and I have one up here stuck down. A little guy like this with a few little relay cards and a bit of other fanciness. And my favourite magpies have come in to interfere with this video too. You can probably hear them in the background. Anyway, they're currently staring at the very beam that I am in question about. So this doorbell may go off if they fly through that. Anyway, recently I've had some nuisance trips. People have been deliberately setting it off as a means of harassment. Now, I did have another video in the making about how I was going to deal with that, but for legal reasons we won't be showing that video. I've had to abandon that. I won't elaborate any further on that, guys, but I have decided that I would like a log of the date and time when the doorbell is triggered. Now, obviously I have a camera looking down that beam with a motion sense on it, but as you know, cameras with motion sensing can trip for all sorts of reasons. This beam is a little bit more robust. It doesn't just go off every time a moth flies through it. So, in my desk here, I have a little auxiliary computer on this switch here, and that is actually an AT Mega that's in there, an Arduino. So I'm thinking about attaching a real-time clock to that, and then these two wires here I have wired across, just across the LED here, in series with the LED resistor. So that gives me about 1 volt on here. I'm thinking of either running it through an optocoupler or one of these relay boards, and then patch it into this. Off to the side here somewhere, in amongst all my box of bits, I think I have some real-time clock modules that I can add on there as well. Probably not in that box. I have all sorts of boxes of interesting stuff laying around here. That doesn't appear to be it either. Somewhere I have some RTC modules. I'm relatively confident they are in this box. Yes, they are. Let's have a look. So I have these little DS3231s, are they? Yes. DS32S31SN real-time clocks, and they have a little battery. I need to check if the batteries are charged. They're usually flat on these. But I have some supercapacitors that might take their mark as well. Anyway, that will allow me to keep a real-time clock, and hopefully I can get this guy to keep a log of date and time. I'm obviously going to need that to store it somewhere. So I do have some Raspberry Pis that might do the job even better. I'm not sure how I'm going to go about that yet, but I think Raspberry Pi might be an option, and I can have them drive those displays. I'll have a bit of a think, but right now the first thing I need to do is to get this doorbell interfaced with something. So I'm not going to bother opening this up and going through the process of attaching this, because I did that quite some time ago with a view to doing this. It's just taken me about 3 years to getting around to it. So that's our project sort of explained. So let's have a look over at some schematics. Let's look at our schematics and ignore the time here. That was just of an event that happened that I wanted to look up. So if we ignore that, we have 2 wires coming out of here, which is just a piece of twisted pair from a Cat5 cable. We have our stripe and our solid, or if you're of that nature, you might want to see a trace, might be the terminology you use. I once worked for somebody that got kind of pissy with me because I used the word stripe instead of trace. However, that stuck in my brain a lot better. The other gripe we also had was about me wiring things as B-type wiring, which is the US standard, when the Australian standard called for A-type wiring on, what are they, RJ45 connectors for Cat5 cable. And that's because I was trained to MCSE standards, which calls for B-type wiring, and he wanted with the Australian type as A-type wiring. But anyway, at least he knows where I've been. So Anyway, what we've got here is I hooked an LED up to this just to determine the polarity because I'd forgotten. And so I hooked the stripe wire up to the cathode and the solid wire up to the anode, and it fired up, which means that our stripe wire is negative and our solid wire is positive, and we're getting around about 1 volt, just a tiny bit over that. That should be enough to trip this relay board. So I'm going to hook it up to a 9-volt battery and put a couple of clip leads on or whatnot, and we'll see if this clicks when the doorbell goes off. So let's have a look. It seems I've used all my doorbell or my 9-volt batteries for doorbells and other things, including a nuisance box that I have now lost. It's a button with, oh no, here it is. It's a nuisance box to annoy my apprentice. During COVID, my wife and senior financial manager, who's a crossing guard, needed a synthetic whistle. They ended up buying a little rubber thing that's called a squishel, which worked really well, but I was going to make a synthetic whistle out of that. So in the end, I just abandoned it and left it as a button beeper and a 9-volt battery in a box, and my apprentice hates it. I should dig out the story of the Eeyore box at some point for everybody to see. Anyway, I get these things confused regularly with the polarity, so we are going to see which one is what. So that is our negative wire on that side. The big one's our positive. Okay, that's good. So we're going to hook these guys up. Because I can't find my 9-volt batteries, we have to power this from the 9-volt side on my panel, which we're going to zoom up and have a look at. This is my test panel that I have various regulators built into. We're going to hook this up to the 9-volt side, which is lighting up at 9 volts. And this is 12 volt from the house battery, which is about 13.5 at the moment. And I also have a 5 volt, and this one feeds down from the variable supply, which is switched off right now. And I've also got USB charging and continuity outputs. And the beeper is super loud, so I've covered it half up with blue tack. All right. Now, I need to see if I can trip this with a resistor first. I have a mystery resistor here. And I'm not sure if this needed to be grounded or if it needed to be pulled up or pulled down. For this, we're going to pull it up. No, let's pull it down. This resistor is probably way too high. What else have we got up here? I have a big roll of 390s, I think. What's that look like? That's way above 390. That's kind of like mega ohms almost. Give me a minute to find one. What's this roll over here? We have a roll of these guys, which are, they look like no, there's something else. Yeah, they're 390s. I'm sure of it. I should have written it on here. Yeah, 392% metal films. Okay. Because I'm reading, and I've done this a few times on camera, but we are looking at what's that? Yeah, that's orange, which I think is 3, white, which I think is 9, and 002. So one black is 0, so 3, 9, 0, and 0 multipliers, and then red, which I think is 2, which means it's probably a 2%, and the blue colouring indicates it's a metal film resistor. So 390 is usually enough current to trip these things, and I seem to recall this one is pulled low, which is why it's in here. Let's pull you high then. Yeah, okay, we pull it high. Okay, and about 390 is about the current I use to light an LED, so I think this might work. Let's solder this together and see if I can blow up my doorbell. So let's take a look here. We've got a notepad over the side here. Now, crucially, I have disconnected this from my test supply because the stupid inverter in the house, or regular UPS in the house, has created a ground to my battery ground as well. So we want to go across positive and that center wire. So we are taking positive across there. So let's take our negative wire, which is our stripe, onto this. I don't know if this is going to be advisable, but we'll see if she works. Alright, we'll do that. See if the 1 volt difference across there is enough. And crucially, we're not sharing ground to the doorbell, and the doorbell is on battery. So now let's plug everything in. Smoke test time. Let's fire up the 9 volts on this side. And let's run the test on this. Now, I wonder if I'll hear this clicking at the top. I'll see if I can feel it when I push the test button on the doorbell. It clicked. Oh, shut up. Where's the short one? I can't shut it up. Okay, the doorbell, okay, it does drop. I felt it, I don't know if you heard it click, but I certainly felt it engage with that light. So that method is going to work very well. I think I'm going to stick with that because I know a lot more about interfacing relays with Arduinos and Raspberry Pis than I do optocouplers, even though I've done that a few times. That, and I don't know what I've done with all my optocouplers anyway. This was already made and sitting in my desk. So now let's see if I can figure out how to get a real-time clock and get some storage on an Arduino. I don't know how I'm going to do that. Although they do have a fair bit of RAM, so I guess if I leave it on, I can have it display all the motion events in RAM and cycle through the screen. I'm going to do some thinking. We'll be back. So halfway through this, I just started getting a whole bunch of random triggers. So I thought I'd go out and find out what was wrong with the bell. Turns out it's full of ants, which I now need to clean off my desk. Give me a moment. So it turns out there was a few live ones underneath there that I wasn't aware of, but a bit of good old surface cleaner slowed them down. Now, rather than clean that out and have dead ants and live ants all over my desk, I had to dig around in the shed, and I have a spare kit. I'm just going to replace it for now, and I'll refurb the old one when I get to it. So this one is probably a receiver. I think we'll find out. Oh, that's a transmitter. It says on the back. I'm making that one the receiver. And so yeah, basically both ends of these look fairly much identical. It's just that the transmitter has a relay in it. This is just the repeater side of things, which is the one that they've got into. So we'll have a look here. I'll give you a look at what's actually inside them. I had a look through the lenses in that other one. There are ants that I've actually got inside behind this lens. So this guy is pretty well at 90 degrees where I have it sat. Oh, receiver. Okay, yeah, this is the other end. This one's got all the relay contacts and everything in it. This is not the one we want. It's not the droid we're looking for. This one, fortunately, is. And I'll be heavily covering the area in surface spray. I think we need to get the pest controllers back in again at some point. Okay, so this guy needs to rotate around about that way. And we need some self-tapping screws that I had kicking around. That are now MIA. I'll find some of them, I'll go out, refit this, and we'll be back on with the project. Alright, that's the repeater replaced, and it's working more reliably now. I'll do it, and probably at the end of this video, I'll do an autopsy on that. It'll probably work again, I just want to get all the ants out of it, and that requires advanced disassembly. Now, I looked at my options here behind getting this to work as a logger. Now, I'm going to need some way to store the data, so I thought about getting an SD card module. What I'm thinking I'm going to do is I'm going to worry about all that later. For the time being, up on the top of my desk here, I have my multimedia machine here, which is a Raspberry Pi 4 with a GPIO accessible. under this nice aluminium cover. So what I'm thinking, that runs pretty well 24/7. I just switch over to the HDMI when I need it. It runs off the TV over the side here. So I'm currently halfway through an episode of Star Trek whilst I'm working as well. So classic Star Trek, guys. It's worth getting into. Additionally, I also have a backup power supply here, a UPS unit attached. So it's all handy stuff. I think what I might do is feed that relay input into the GPIO of the Raspberry Pi 4. It's already network connected and has loads of storage on it. I think that's going to be the easiest way. Also, my doorbell sits up here, so the cable path runs right down beside that. And I can probably get power from one of these 12-volt sources up here somewhere very easily as well, and run it down to a 7809 regulator to run this guy. Although I think this might run off 12 as well. We'll find out. That, or I'll just whack a couple of diodes in series with it. So yeah, that's the way I think I'm going to go. So now I've got to refresh my memory on Python and shell scripts. So I'll be back once I've done more homework on that. Alright, so where we're at now, I've managed to enable SSH on that Raspberry Pi 4 we looked at earlier. And I'm going to go ahead and install Python and get shell scripts all worked out and get the Raspberry Pi libraries enabled. What I'm probably going to do from here, just really quickly, I'm going to run raspberry config. -config. Type in left-handed here, guys. And I put a slash on, so let's cancel that. Alright, anyway, last command is that. There we go. No sudo. Alright, that's right, because I'm already logged in as root. Don't need to run as a super user. Raspberry config's not installed. Okay, I've got a lot to do. Anyway, we'll be back. Alright, I've been a little bit busy and I remembered a few things. So, for a start, I realized I was using LibreLec, which basically doesn't allow you to make changes to the operating system, which is kind of good. It makes it hard for somebody to hack in via SSH and screw with stuff. It does kind of present a bit of a problem for me when I want to install things like raspberry config. Anyway, I don't need it. I found that from another tutorial on how to make a power button on LibreLec, they said there is actually an add-on through the GUI that you can install called Raspberry Pi Tools that enables the GPIO library in Python. Python's already installed, cron is already enabled, I've got SSH, so I'm pretty well ready to start working on my button press Python script, and then I can have it start at reboot with cron, which will be nice. So I'm going to get to it, and we'll be back with what I managed to get working. Alright, we've had some success, so let me go over what we need to do with the programming. So in LibreLec we have to add an extra line here. We have to import system files and specifically the Kodi add-on. Then we import RPI as GPIO. So import the libraries from there. Without these top two lines, this line here won't do anything. It'll go, hey, we need to load the libraries. Now I've loaded up the GPIO pins in Broadcom pin numbering. This notation is wrong now. We're actually using the Broadcom pin numbering. And now I'm using GPIO 21 on the very end. I'm using the pull-up resistor to pull the pin high, and then I'm waiting till the pin is pulled low to ground. That means I don't really necessarily need to use a resistor now. And it's a bit safer if something goes wrong or if it shorts out, whatever. So I'm just going to test that this works. So we're going to exit this. We're going to go up a couple. We're going to run the program, and then I'm going to go over to the Pi and we'll have a look at that. It's going to be a little difficult given the lighting and my position, but we can see here I'm running pin 21, or sorry, GPIO 21 and ground, which is pin 39 and 40. And if we bridge these guys, we'll sit over here and have a look at what happens when I bridge the wires. Let's bridge two wires together and see what happens. Bridging, not bridging. Bridging, where are we? Oh, I dropped the wires. Bridging, not bridging. Okay, that's good. So it works. Now let's see if we can get it to actually not repeat while the button's holding down and also write that event to a file.
Maybe you haven't noticed, but no one's laughing. Now I know it's hot. We're filthy, tired, and we've got 10 isotons of it.
Alright, so I made a quick little change. I've added import time, changed my notation to say Broadcom pin numbering. I've added a 5-second sleep time and a print to tell me when the sleep's finished. Just for diagnostic. So let's sit back down here. We're going to go Control X for exit. Oh, I'm not on the right side of things here. Control X here. Run doorbell circuit or doorbell Python. We will push the button and it'll wait a moment and then it should go sleep finished in 5 seconds. Now if I'm holding this down, it should trip only once every 5 seconds now. So if we keep watching, it'll trip every 5 seconds. That's much better. Okay, that's about the amount of time it takes for the doorbell to go off, and I can adjust that pretty easily from that. Okay, we'll cancel that out. Now I've got to make it write to a file. Alright, we've got our code pretty well set up now. So I'm going to comment at a couple of lines here. I'm going to leave the sleep in. I'm going to comment out button was pushed, sleep finished, and not going to bother having it show the date time in the log. Just going to have it run quietly. Now I've got it opening the file each repetition, because if I have it opening the file up here, when it closes it and then can't write to it anymore, because it's going to stay inside this while loop. So it's going to write to my doorbell log. I'm going to rename that as CSV, and I'll explain that why in a minute. So now it's doing a file write, and it writes the string for the current time, formatted with the day, month, year, and the hour, minute, second on here. So that should put it out, and it adds a comma in here. That's because I'm going to use comma separated values. So when I open this, it'll open in an Excel spreadsheet and put all the values in their own rows, which will be handy if I want to search for stuff or filter things out, like to a particular hour. And then it closes and it prints now on here. I think I can piss that line off as well. I don't need that either. So let's get this all sorted. Alright, so here's the output of our log file, and it's separating the dates and times into comma separated values. I might actually have it put a comma between the date and the time, which will help me concatenate things a little bit easier. So I'll do that, and I'll make a quick change to the code. We'll clean it all up, and I'll give you a quick look at that, and then we'll get back into the hardware. Alright, so I've had it spit out a CSV file, and I also added a command to add a new line, so that makes it easy. I've got comma separated values in new rows. That's handy. Let's take a quick look at this code. Alright, this is my clean code, and I've left the notations in. Some of these notations were in from some of the tutorials that I copied and pasted to get this in here. Because I just can't get Python to stick in my brain, I have to look it up a little bit every time to refresh my memory. Anyway, basically what's happening, aside from importing everything, we've already discussed all of that. We are writing to a CSV file, we are opening to append, then we're now writing the string for the current time with day, month, year, hour, minute, seconds on a new line with commas separating it. Then we're closing it. Next time it's done again, it's going to open that file. Next time this true loop runs, and it's going to wait for 5 seconds in between those loops. I can go in fairly easily and change these things, and it's going to spit it out as a doorbell log CSV file. I can map a network drive to that, or a shortcut, fairly easily, and then I can delete that and it'll just rewrite and recreate the file again. Alright, let's get back to hardware stuff. Alright, now we're back to the hardware side of things, and I realise now that I've probably forgotten to set that script to run at startup, but we'll find out how to do that. I'm pretty sure this is the normally open contacts on this. Let's just check that out for a minute. Continuity beep, and so they're normally open or normally closed. You're normally closed, so that's the common. Don't know what that is. And you're the common, and you should be, I guess that's normally open. I'm pretty pretty sure that's what that was. It's been a while since I've worked with these little modules. Yeah. Oh well. Alright, we'll go with that one, and if it doesn't work, then we'll investigate. Let's snip these guys off. And now you'll notice that I used these little DuPont connectors on the Raspberry Pi for testing. And I got a male to female extender. I'm just using a female one here. This just gives me a few options. It means I can connect it up fairly easily. So let's go here. Now I need some venting, some fume extraction overhead here, which is noisy, as you'll hear. The fan cowl fell off it today, so I need to go out and investigate that at some point as well. You know, normally I would trim these off, but I think in this case it really doesn't matter, the length of these guys. Now, I probably need to find a 9-volt battery to run this off for temporary testing, but because I'm a bit worried about the ground looping and stuff, because my Raspberry Pi runs on the same supply. I didn't think of that. Anyway, we'll hook this up, give it 9 volts and see what happens. Alright, so we're temporarily set up. The doorbell's in its nice, highly elevated spot where it gets good reception. We're running down to our relay unit. I now realise that isolation of power supplies is not an issue because I'm using a relay. And so it's battery on that side, house battery that side, and it's isolated on the Raspberry Pi, which is why I use relays in the first place. Optocouplers can provide the same level of isolation too. But anyway, I'm going to go outside and see if it trips. So I've got the script running over terminal at the moment. I haven't set it to run at boot. I'm going to go walk through the beam a few times and see what happens. Difficult to do that with one person and one camera, so we'll see how we go. Alright, we've got our temporary power set up that I had to run up here. I've got it all working. I've been out, run through the doorbell, and it created a log file here in CSV, and it's created a new entry that shows the date and time, and down to the second that every time the doorbell was triggered. That's nifty. Now I can correlate that to footage. I can find out if it was triggered while I was away or whatnot, and I won't miss definite things that have crossed into the yard. No doubt I'm going to get lots of magpie footage, but anyway, they've learnt that they can come in and do a banking turn, trip the doorbell, we'll come out, see them and feed them. So I do get nuisance doorbell trips from the magpies. I'm going to have to find some way to modify that behavior. But anyway, yeah, let's move on to making the 9-volt regulator for it. Alright, this is where we get back to my roots a little bit. Now, I had this interesting plan of taking a few things here, namely this little DC socket, and hooking up a regulator in the middle onto this little 9-volt clip, and clipping onto this clip, and reversing the polarity and mucking around, and I reckon that's a recipe for disaster. So I decided instead I'm going to do away with the clips. I'm going to wire it directly. Now I had a look through my parts and I didn't have an LM7809, I had an LM7810. That's a 10-volt regulator, linear regulator, but with 2 half-volt dropping diodes I can bring that down to 9 volts. And then I thought, well, why am I using an inline plug when I can find a nice little battery box to fit it in, and I have a shit ton of these things. Whereas I've only got one of these guys left, so I've got about 50 or 60 of those guys. So I might build it all into a box, and this little relay fits nicely in there. And then it's easy to unplug when I want to change batteries in the doorbell, which I will be doing soon too. They're getting a little flat after all of this. So let's get cracking with this assembly. Alright, I've been busy the last probably 15-20 minutes. So we have an LM7810 here, and we have 12-volt DC input here, and 2 diodes, and I hope I've got them the right way. I haven't tested this yet. But common ground in the center here, and we have an input and an output through here. So it should be all good. Right, it is smoke test time. I'm going to go 20-volt range on the meter here. And position it in such a way that you guys can actually read it. So half the problem here is the camera angles. There we go, I think you can. Let's put backlight on. That should make it a bit easier. Alright, we'll pick this up to our overhead connection, which could make testing this a little difficult. I've lost all my test leads, so, oh, there's a positive wire here. We're already detecting a bit of power. Negative wire, we're getting 0. I think I got the diodes backwards. Yay, I have to undo the heat shrink. Yep, definitely got diodes backwards. Alright, let's figure this out. So I cocked up a little bit. I had my input and output side wrong on the LM7810. Alright, now we're going to do our same little tests here. We're going to test either side of the regulator and see what our voltage is. So we're going to use off the back of this regulator here, we're going to take one wire off that, and we're going to check our input voltage. Oh, no, sorry, our output voltage to the unit. Let's turn our backlight on here so you guys can see, and hopefully our focus works while I balance everything in here. So we've got a nice 9.4 volts there. Come on, focus, see, 9.4 volts. Alright, I did check on the other side before I put the heat shrink on, and we're about 10.2. So that 1 volt drop across those diodes is very nice. So let's get it all packed into a box. Right, so here it is. This box didn't respond very well to being trimmed with flush cutters, but it's going to keep it all compact and well insulated. And crucially, if I find out I've done something silly like hang a wire out, I can open this and stuff the wires back in. Much like how I fit into my shorts these days. Alright, that should do the job. It's not going to short out on stuff. And it's isolated. So and that relay is not going to draw anywhere near the half amp that these things will provide. And it's probably not even going to get hot running the milliamps that it is to switch a transistor or to keep that whole circuit idle. So let's get this installed and do a final test. Right, we're very nearly done. We're just up to changing batteries in the doorbell, or the receiver itself. These are always a nightmare to get into, these packets. Where's my Leatherman? Actually, I nearly always cut my hand off when I use my Leatherman. Let's try some scissors. I'm going to take all these out and put them in my battery box anyway. So now I've added the Python script to the autostart.sh shell script in Librelec because I didn't seem to work with cron. That doesn't really matter. At least it runs at startup now. Went and moved my vehicle and drove in and out of the beam and tested it. And it works and it logs and it creates the file if I've even deleted it, which is nice. Now, these ones actually have a bit of these are a bit of a pain. And as usual, Bluetooth to the rest, or Blue Attack to the rescue. I'm getting hungry, so my speech is getting out of whack. I also don't multitask all that well. I only wonder why these were going a bit flat. Alright, hold up one moment. Well, there was some loud smashing sounds going on outside. There goes another one. Not sure what that is. I think my neighbours are having a blue again. Part of the reason why I've got this up. Anyway, put some new batteries in here. Now, I've got to put this one in first, then this one in the middle, I believe. Alright, that should be good. Okay. And I'll set the doorbell sound in a minute. These can go in my recycling bin, and we'll be back. Right, we're going to do a last and final test here. I can find my mouse. I'm going to delete the CSV file, and we're going to go up and have a look at what we've done here. I've taken the magnetic lid off this case here, and these are actually really nice, robust cases, by the way. They're the Neo cases there, aluminium cases for the unit. I've put a little nick in the corner so the cable can hide out there. I've hooked everything up. Now I've got to set my tone. Yeah, sick of that one. That one's a good one. Okay, and I heard that relay click in the box. I like this one. Previously, people had been walking past and they could hear, or when they're trying to sneak across my lawn, crucially, they can hear this go off from outside immediately. So the buzzer I had attached to it with a 6-second delay wasn't really effective. It did fool some of them into thinking that the beam was a bit differently located to where it actually is. But in this case, I've switched that. I've basically covered up the lights. I've disconnected the beeper and I've switched to the quieter doorbell trigger, so it's not as obvious from the front yard that they've triggered anything. Mostly because that was becoming a source of nuisance triggering. So at the moment, I'm hoping they think I've disconnected the thing. Anyway, let's see if it's created that file. So let's go over here and do a refresh. And it has indeed created a CSV file. And it's going to give us date and time. Awesome. Awesome sauce. Okay, so this works. So I'm just going to put my batteries back in my storage box with all my other batteries. And we're pretty well done. I'm pleased with that. Now, if I go away, I can come back and find out when somebody or something has crossed my front yard, or when my thing gets infested with ants. And I think I'm going to do an autopsy in a separate video on that damaged sensor. So if you're interested about that, I've got to clean my keyboard, but if you're interested about the autopsy on that, hang around for my next videos. I'll probably be doing that in the next day or so, when I can be bothered dismantling a thing full of ants. Alright, we'll see you in the next video. I hope you had fun, and yeah, hopefully these MS rashes go away soon. But that's a story for another day. See you later.